This is SpaceTime, Series 24, Episode 29. Coming up on SpaceTime, the new Mars Perseverance rover undertakes its first drive on the Red Planet. The most comprehensive map ever achieved of binary star systems within the Sun's neighbourhood. And Moscow launches a new satellite to monitor Russia's northern frontier. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's new Mars 2020 Perseverance rover has undertaken its first tentative test drive across the surface of the Red Planet. The trek, only about 6.5 metres, was designed simply to test the car-sized six-wheel science lab's mobility following its violent launch from Earth, the freezing cold 7-month journey from Earth to Mars, and its rigorous entry, descent and landing into Jezero Crater. Still, the mobility test marks one of many milestones on mission managers' checklists as they calibrate every system, every subsystem and instrument on both Perseverance and its companion helicopter drone Ingenuity. The drive, which lasted about 33 minutes, propelled the rover forward by 4 metres. It then turned in place 150 degrees to the left and backed up 2.5 metres to a new temporary parking spot. Once the rover begins pursuing its scientific goals, regular commutes extending 200 metres or more are expected. A key objective of Perseverance's mission on Mars is astrobiology, including a search for signs of ancient microbial life. The rover will also characterise the Martian geology and past climate. It'll pave the way for future human exploration of the Red Planet, and it will be the first mission to collect and save Martian rock and regolith for future sample collection and return to Earth. Subsequent NASA missions in cooperation with the European Space Agency will then send a sample return mission to Mars to collect these sealed samples from the surface and return them to Earth for in-depth analysis. The Mars 2020 Perseverance mission is all part of NASA's Moon to Mars exploration approach, which includes Artemis missions to the Moon that will help prepare for human exploration of the Red Planet. The rover's mobility system is not the only thing getting a test drive during this period of initial checkouts. Perseverance has also received a software update, replacing the computer program that helped land Perseverance with the one it will rely on to investigate the Red Planet. Mission managers also checked out Perseverance's radar imager for Mars Subsurface Experiment and its Mars Oxygen In Situ Resource Utilization Experiment instruments. They then deployed the Mars Environmental Dynamics Analyzer Instrument's 2 wind sensors, which extend out from the rover's mast. Another significant milestone occurred on Mars or Sol Day 12, when engineers unstowed the rover's 2-metre-long robotic arm for the first time, flexing each of its 5 joints over the course of 2 hours. The robotic arm's the main tool the science team will use to do close-up examinations of geologic features, and it will drill and sample the ones they find most interesting. Upcoming events and evaluations over the next week or so will include more detailed testing and calibration of the science instruments, sending the rover on longer drives, and jettisoning the covers that shield part of the rover's sample caching system and the Ingenuity Mars helicopter during landing. The experimental flight test program for the Ingenuity helicopter will also take place during the rover's commissioning. Meanwhile, while all this has been going on, mission cameras have been busy. They've already sent back more than 7,000 images. This is SpaceTime. Still to come, astronomers developed the most comprehensive map ever achieved of binary star systems within the Sun's neighbourhood, and Moscow launches a new satellite to monitor Russia's northern frontier. All that and more still to come on SpaceTime. Astronomers have developed the most comprehensive map ever achieved of binary star systems within the Sun's local neighbourhood. The new three-dimensional map is based on data gathered by the European Space Agency's Gaia spacecraft and covers some 1.3 million binary star systems out to a distance of 3,000 light-years from the Sun. The findings, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, represents the most complete survey of its kind ever developed, dwarfing the previous atlas compiled by the now defunct Hipparcos satellite, which surveyed around 200 binaries. Binary star systems, which consist of two stars orbiting each other around a common centre of gravity, make up at least half of all Sun-like stars and white dwarf systems. In fact, most star systems in the Milky Way are multiple systems. Solo star systems like our Sun's are very unusual. Gaia was launched in 2013 to precisely measure the distances and motions of millions of stars. Its latest data set includes 17,000 white dwarfs, the dead corpses of Sun-like stars. There are also 1,400 binary star systems in the new catalogue, which are composed of two white dwarfs, and 16,000 binaries that consist of a white dwarf and another type of star. The vast majority of the 2.6 million stars in the new map are still on the main sequence, steadily fusing hydrogen into helium in their core, just like our Sun. The data shows that about half of all Sun-like stars are in binaries, many of them too close to distinguish. But about 25% of all Sun-like stars have a binary companion with separations greater than the distance between the Sun and Pluto, and some are separated by as much as 3.6 light-years. The data shows that the stars in most binary systems orbit each other within 1,000 times the distance between the Earth and the Sun. And the new analysis also confirms something that was only hinted at in earlier data. Many binary star pairs are very similar in mass. And when you think about it, that's really weird, because most of these stellar pairs are so far apart that, by conventional star formation theories, their masses should be random. The massive sample size in this survey means it's possible for astronomers to undertake population demographics, looking at the distribution of mass ratios of the two stars in each system and how their separations or eccentricities are distributed. Prior to Gaia, the only way to find binaries was to look for stars close together in the sky. And that can be tricky, because just because stars look like they're very close together from here on Earth, they could actually be hundreds of thousands of light years from each other, merely sitting along the same line of sight. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
They've just released this incredible atlas of star systems that are being studied by Gaia. This sounds very exciting indeed.
It is actually. It's a slightly esoteric because it's the stuff of astronomy is binary stars. Well, just to recap on Gaia, Gaia is a space observatory, as you've said. It's run by the European Space Agency, and its mission is the very accurate determination of star positions over time. So not only do you get a snapshot at any given time of the exact positions of stars down to levels of micro-arc seconds, which are really unbelievable to a ground-based astronomer, where the atmosphere smears everything out to within 2 or 3 arc seconds. So its mission is to measure those positions, but of course, when you observe over time, you can see how stars move, how they drift through space. And that's what's allowed this new catalogue of binary stars. What are binary stars? They're stars that are connected by gravity, a pair of stars that are in orbit around their common centre of gravity, rather than just what you might call a double star, and amateur astronomers are very familiar with double stars. They're stars that look like a pair, but sometimes one is 1,000 light years behind the other, because they may well be what are called optical double stars, where they just look as though they're together, but they're actually a line of sight accident. Astronomers are interested in binary stars because the thinking is that when you come to sun-like stars like the Sun, about half of all sun-like stars should be in binary pairs. And that's really a very interesting statistic, because the catalogues of binary stars until now have been much smaller. I've been slightly involved with this kind of thing, but from a different perspective. When we were doing the RAVE experiment, the radial velocity experiment, one of the ways of detecting binary stars is to look for the changing velocities of stars as they orbit around one another. They're ones that you don't see as two separate stars. All you can tell is that there's two, because there's the spectrum of the pair actually combines. And we found, I don't know how many it was a few dozen, I think, from the RAVE catalogue. A previous space astrometry observatory, and astrometry is the science of accurately measuring the positions of stars. In fact, Gaia's predecessor in many ways was called Hipparcos. I remember I think it was 82, I was at a meeting where we were planning what Hipparchus might do. And now it's long gone and there's a super-duper replacement with Gaia. But Hipparchus had a catalogue of something like 200 binaries from its data catalogue. Whereas the Gaia sample now, they've just produced this catalogue of fairly widely separated binary stars within 3,000 light years of Earth, and they've got 1.3 million of them. So it's a much, much bigger catalogue. And of course, that actually allows you to do all kinds of statistics, because binaries aren't just sun-like stars. Many of them are white dwarf stars. Sometimes you've got white dwarf star with a normal star companion. White dwarfs are what our sun will end up as in about 4 billion, 5 billion years' time.
Yeah.
All of that stuff falls into the catalogue of all these stars. So how have they done it? Well, what they've done, it's been really quite clever. They've been looking specifically for binary stars that are relatively widely separated, so it takes them a long time to make one orbit around each other. And that's a bit difficult to measure with the kind of equipment, certainly, that we're using with RAVE. But with Gaia, what you can do is you can look at the motion through space of all the stars, and you can essentially, you're not just looking for stars that are close together in the sky, you're looking for stars that have they're close together, but they also have a common motion through the sky. So, and you can also, the other thing you can do is because Gaia can measure the distances of stars, you can check out that they're both at the same distance. So those are the parameters. You've got a pair of stars, they check out to be at the same distance from the solar system, and they are moving together the same direction in space. That tells you that you've got a real binary pair. And so, Gaia is essentially doing this work and has produced this catalogue. Actually, some of the people involved are people I know because they were involved with the RAVE programme. Hans-Walter Rix of the Max Planck Institute for Astronomy in Heidelberg, he's one of them. So they have looked for binary stars that are separated by 10 times the distance between the Earth and the Sun, or 10 or more times. These are the sort of widely spaced ones. And what you get is something like, I think what in their measurements, they've actually measured that 25% of all sun-like stars have a binary companion. That separation's more than about, actually these are quite distant, more than about 30 times the Earth's distance from the Sun, which is more or less the same distance from the Sun to Pluto.
Oh, okay.
And he said it's really interesting. The distribution peaks at a separation of 30 or 50 astronomical units, 30 or 50 times the distance to the Sun. That's really quite curious phenomenon to find what distance you have the most of these pairs, and it must tell us something about the evolution of binary stars.
Well, we've talked before about our sun having had a partner at some stage, whether or not it was a binary or if it was just I think we have referred to it as a binary, and it's drifted off somewhere. Just imagine, though, if it sort of was at the distance of Pluto, what would our solar system be like then? I mean, when you look at the sun from Pluto, it's not very big. But if there was another one around that region, things would be very different, wouldn't they?
That's exactly right, they would. It may well be that the Sun had a companion back in the early history of the solar system, 4.6 billion years ago, that has now drifted off, that's now become freed from the gravitational attraction of the pair. And this plays into one of the things that has been discovered from this new catalogue. And I'm quoting one of the authors here. One thing we found that is cool, we discovered this with Gaia, but we can now study it better with the new sample, is that binaries like to be identical twins. So they're stars that are very, very similar in mass. Many binary star pairs are similar in mass. So if you've got one sun-like star, you've got another sun-like star. And he says that is really weird because most of them are separated by hundreds or thousands of astronomical units, one astronomical unit being the distance of the Earth to the Sun. So they are so far apart that by conventional star formation theories, their masses should be random. But the data tells a different story. They know something about their companions' masses. And the implication is that they formed much closer together, some sort of process that tended to equalize their masses and then migrated apart.
Yeah.
Maybe because of interactions with other stars. Remember that the sun and most of the stars that we know actually are formed in clusters. So they, like the Pleiades, the seven sisters, that's actually got 200 stars in it or thereabouts. It's about 10 million years old, and those stars are typical of the kind of environment in which the sun formed. So yeah, migrating apart is basically what happens, and that looks as though that is how the sun lost its sibling, wherever it may be.
Yeah. So now that they've created this catalogue, this 3D catalogue of binary stars and systems, as you said, 1.3 million of them within 3,000 light years of Earth. What are they going to do with it? What will it be useful for?
Well, the sort of thing that we've been talking about, discovering what the conditions were like when these objects were formed. So that very thing, and it's actually Karim El-Badri, who's the author who I just quoted there, the very thing that he was saying, that the normal star formation theories tells you that masses of stars should be random. But here you've got these widely separated pairs that are identical. So that immediately starts people looking back at their theories of star formation, the way stars form in clusters. That's the kind of thing that happens when you've got a really nice and large catalogue of any different class of object, whether it's quasars or galaxies or whatever. A large catalogue of samples lets you see the trends within it, and that's basically that they're further apart than you expect them to be. And it also lets you find the oddballs as well. That's one of the other things that catalogues do.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come, a new satellite to monitor Russia's northern frontier. And later in the science report, a new study has shown that the South African variant of the COVID-19 virus is even stronger than previously thought. All that and more still to come on Space Time. Russia has launched its first Arctic climate satellite. The Arktika-M spacecraft was launched aboard a Soyuz 21B rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The 2,100-kilogram probe is based on a Russian Electro-L meteorological satellite and is equipped with multispectral infrared spectrometers as well as communications transponders for both meteorological and emergency rescue services. The spacecraft was placed into a highly elliptical 12-hour Molniya orbit, which ranges in distance from 1,043 out to 39,727 kilometres, which allows maximum dwell time above the Arctic Circle. A second identical satellite will be launched in 2023, allowing Moscow to maintain continuous all-weather monitoring of its northern frontier region. And that's an area growing in importance as climate change opens up new shipping routes and huge oil and gas reserves, which are being eyed off by Russia as well as other countries, including the United States, Canada and Norway. Last month, British scientists reported ice was disappearing across the world at a rate that matched worst-case climate warming scenarios. The authors of that study, from the universities of Edinburgh, Leeds and University College London, found that some of the largest losses over the past 3 decades were from Arctic sea ice. Meanwhile, Russia has confirmed that it's planning at least 12 more launches this year from the Baikonur Cosmodrome. That's despite growing use of its Plesetsk and New Vostochny cosmodromes. The Russian Federal Space Agency Roscosmos says 2021 will see at least 3 manned Soyuz missions, 3 Progress cargo ship missions, the launch of 2 new modules for the International Space Station, as well as 2 commercial telecommunications satellites, and 3 launches of OneWeb broadband internet satellites, all taking place from the Kazakhstan facility. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that antibodies from recovered COVID-19 patients and from vaccinated people are between 9 and 12 times less able to neutralise the South African variant of the SARS-CoV-2 virus compared to the original China virus. Both the UK and South African variants of the deadly disease were shown to have increased resistance to antibody neutralisation in laboratory experiments. But the UK variant was not resistant to plasma from patients who had recovered from COVID-19 and sera or blood fluid from individuals who were vaccinated. A report in the journal Nature suggests that SARS-CoV-2 is now mutating in a way that may cause it to evade current interventions, and that revised therapeutics will be needed. The authors say this underscores the need to stop virus transmission as quickly as possible by redoubling mitigation measures and expediting vaccine rollout. Almost 2.7 million people have now died from the COVID-19 virus, with another 120 million infected since the deadly disease first emerged from Wuhan, China, and spread around the world. A new study claims making room for shrooms could improve your antioxidant levels and help control blood sugar as well. Scientists fortified wheat noodles with powders created from the caps or stems of different types of mushrooms, and then measured the effects in a laboratory simulation of digestion. The results, reported in the Journal of Food Chemistry, suggest that the fibre in some mushrooms could be beneficial for slowing down the release of sugar after eating. But the authors say further tests are needed in human trials in order to confirm the results. A new study claims Neanderthals, the closest ancestors to modern humans, possessed the ability to perceive and produce human speech. The findings, reported in the journal Nature, Ecology and Evolution, are based on a reconstruction of how Neanderthals heard sound, which in turn provides some inferences about how they may have communicated. The authors used high-resolution CT scans to create virtual 3D models of ear structures in Homo sapiens, Neanderthals, and in an early pre-Neanderthal ancestor fossil. The data shows that Neanderthals had slightly better hearing than their ancestors and were very similar to modern humans. Scientists say the presence of similar hearing abilities suggests that Neanderthals possessed a communication system similar to that of modern humans. The International Atomic Energy Agency says it's deeply concerned about the possible presence of nuclear material at an undeclared site in Iran. The United Nations nuclear watchdog says that after 18 months, Iran has still not provided the necessary full and technically credible explanation for the presence of the nuclear material residue in the Turghazabad district of Tehran, one of several secret nuclear sites previously identified by Israel. The site appears to be used for storing enriched uranium as late as the end of 2018. Meanwhile, a separate report issued by the International Atomic Energy Agency says the Islamic Republic's stockpile of enriched uranium is now more than 14 times over the limit it agreed to under the 2015 United Nations Nuclear Non-Proliferation Treaty. The report says that as of February the 16th, Iran's total enriched uranium stockpile was 2,967.8 kilograms. The limit Tehran agreed to back in the 2015 deal was 300 kilograms. The new report comes as Iran is again restricting nuclear inspectors from accessing some suspected nuclear weapon sites. Britain, France and Germany, the three European nations party to the 2015 nuclear deal, responded to Tehran's latest violations by saying they deeply regretted Iran's decision and underlined the dangerous nature of this decision. Meanwhile, Washington's expressed its concern that Iran is moving in the wrong direction. State Department spokesperson Ned Price told reporters Tehran is moving further away from its nuclear constraints. Iran's supreme leader Ayatollah Ali Khamenei responded to the West's concerns by threatening to start increasing uranium enrichment to 60%. The Islamic Republic is already enriching uranium up to 20%, more than 14 times the limit stipulated under its own nuclear agreement. A new study warns that popular video chat platforms like Zoom and Skype have design flaws that exhaust the human mind and body. With details of the study by Stanford University and how to fix it, we're joined by Alex Zaharov-Reutt from ITWire.com.
Well, Zoom fatigue is where you're having to do Zoom meetings all day, you're looking at the screen, you've got 5 or 6 different screens in front of you of other people, or even just one or two, or even just one, and you can see yourself, and just being in this sort of always on sort of intense meeting situation all day, every day, or several times a week when you never had these sorts of long, hours-long meetings before, can be fatiguing. It can be a heavy cognitive load to have to go through all of this because you've got excessive amounts of what they say is close-up eye contact. And normally, even though, I mean, you're looking at their eyes and they're looking at your eyes, but to them, you look as though you're looking down. When I do video interviews with people, I look up at the camera and I ask the people I'm interviewing to do the same thing so that it appears to the person watching our video that we're looking directly at them. But most people are looking sort of at the eyes of the person in the screen in front of them, but it looks as though you're sort of looking down. So, number one, that's unnatural. You might be taking notes as well. But you sort of, with a camera, you're always on. I know that somebody would be seeing you when you're sitting across the desk from them in a normal meeting, but this is still, it's unnatural. And also seeing yourself, normally you can see a picture of yourself on the screen. So seeing yourself as you're talking to the other person and being able to catch a glimpse, that's also unnatural and it's fatiguing. Then video chats, unless you're on your phone and you can walk around, and if you're sitting in front of a computer, you lose that usual mobility. You can't sort of step up and walk around and make cup of coffee. I mean, you can step up with a laptop or a phone, but then people have this motion and this movement. It can be disrupting for them. And then the cognitive load is a lot higher in video chat. So the number one thing that Stanford really recommends is that, as much as possible, turn off the video so that you're just listening with your voice. It's a little bit like watching a TV show and listening to a radio show. You really can do a lot more if you're listening to a show. But when you're watching TV, I mean, unless you're paying attention, you're not really capturing what's going on. You might have to pause and rewind and go back. You're missing a lot, yeah. The other thing is have audio calls. Not everything has to be a video call. I mean, there's lots of other information. If you just go to stanford.edu, you can look for their Zoom fatigue research there. If you just type Zoom fatigue research into Google, you'll find it. And they've got a lot of detail. But the short version is stop using so much video and rely more on audio if you can.
We all know computer games make an awful lot of money, but it's getting even bigger. Tell me about it.
Yeah, well, esports and gaming streaming, where you're watching other people playing games or you're having games streamed to your devices. So you don't actually have a PlayStation or an Xbox in front of you with a disc or with code. It's actually streaming to you just the way you'd be watching something on Netflix. This is predicted to be worth $3.6 billion by 2025, rising from $2.1 billion predicted for this year. So clearly this is a huge thing. I mean, there are esports millionaires out there. There are young teenagers who've made a lot of money playing these games, winning these games, showing other people how to play these games on YouTube. I wish I was one of these people making millions of dollars from just playing games all day. Unfortunately, most people are not going to be able to attain that, just like there's only a certain number of football players or basketball players in the world. But the forecast is that there'll be over 1 billion esports and games viewers by 2025. This is growing from 800 million by the end of this year. So, you might not think 200 million is that much, but it'll probably grow further. I mean, it really depends on what the political situation of the world is and whether we're in some sort of global war between China and the US. But as long as things keep going, broadband will only get faster. There'll be ever more broadband from the satellites and ever faster ways of transmitting information than optical fibers. And the Asia-Pacific region will represent over 50% of these viewers by 2025. Places like South America is also a huge predicted growth area. This e-gaming and esports and the whole online thing is just continuing to blossom and continuing to sort of niche down into all sorts of different areas that were just dreams back in the early days. I still remember when we had something called See You, See Me, and I remember the first Connectix. Connectix was the brand that Logitech bought out. They had this video camera that was sort of the size of a tennis ball. It plugged into the parallel port of your computer, and it was black and white. It was very low frame rate. Balls. That's right. Well, the frame rate was very low. And back in 1995, I was making 30-second to 1-minute videos, and I was embedding them into a PDF that we were sending out to people who were getting an internet newsletter. So you could do this as far back as 1995. It was extremely primitive and very expensive. Nowadays, we can have 4K high-definition live streams from one side of the world to the other, and we don't blink twice.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.